we are going to look at the difference between qualitative and quantitative analysis. Okay, so qualitative gives us a description, so tells us if an ion is there or not. Okay, and quantitative gives us an amount. Okay, so we can look, if a positive ion is there, we can do either a flame test or a precipitation reaction with sodium hydroxide. And for a negative ion, we can do tests with either silver nitrate, with barium chloride, or with hydrochloric acid. Okay, so for a positive ion, we could look at flame tests and the colours that we would get. Okay, and you need to be happy with the colours. So, for example, potassium ions are lilac, sodium ions are yellow. There are others that you need to be happy with. Okay, there are also tests for positive ions that are reactions with sodium hydroxide solution. Okay, so for example, calcium 2+ gives a white precipitate, and Fe2+ gives a green precipitate. Again, there are others that you need to be happy with. Okay, and what you've looked at so far is when you use these tests, and if you only need to use one, or you need to use both of them. So, for example, calcium, it will give a red flame, and it will give a white precipitate. Aluminium will give no flame, but will also give a white precipitate. Okay, so therefore, the fact that calcium gives you a white precipitate isn't a test for the calcium ion, because it could also be an aluminium ion. So I would need to do both the precipitate test and the flame test to prove that it was calcium. Okay, if I had Fe2+, Fe2+ is the only one that gives a light green precipitate, so if I saw a green precipitate, it definitely would be Fe2+. Okay, I've also got tests for the negative ions. Okay, so that could be for the halides. Right, it could be for carbonates, and it could be for sulfates. Okay, and you need to know that for the iodide chloride bromide, you react it with silver nitrate, and you get different coloured precipitates. So for you would get white for a chloride, cream for a bromide, yellow for an iodide. Okay, for carbonates, you'd react it with hydrochloric acid, and you get carbon dioxide given off. For sulfates, you react it with barium chloride. Okay, so we can look at an example material. Okay, and for example, I could give you a substance. You didn't know what it was. The only information that you had was it was ionic and it was orange. Okay. So from that, you would need to think, okay, what positive ion was there, what negative ion was there. Okay? So I would take a test tube rack. Okay? I would add some sodium hydroxide to each one. Okay, and then I'd add some of my solid to each one. Okay? And I would look at what happened. Okay, that would tell me that iron was present, but wouldn't tell me how much. Okay? Now, what we're going to look at how much is there. Okay, so not only do we need to know, for example, that iron is there, but we need to know how much. Okay, there's an equation that you need to know, and some keywords that you need to be happy with. Okay, so, you need to know what concentration means. Okay, and you need to know what moles means. Okay, so concentration basically means how much there is. Okay, and moles is a particular number of particles. So 1 mole is equal to 6 times 10 to the 24 particles. Okay, so I also know that in carbon, for example, 1 mole is equal to 12 grams, And I know that because the atomic mass of carbon is 12. So 1 mole of sodium would be equal to 23 grams, 1 mole of calcium would be equal to 40 grams. Okay? So, I now need to know what the concentration of these are. Okay? So I've got an equation that I can use. Okay? Okay, so N is equal to the number of moles. C is equal to the concentration. And V is equal to the volume. Okay, so normally this is in litres. Okay, so I can rearrange that equation to work out what the concentration is. Okay, so if I've got, for example, 1 mole of carbon dissolved in 1 litre, my concentration will be 1 divided by 1, which will just be 1. Okay, so I can look at a couple of examples. Okay, so, and we will look at those as examples. So, if I took 20 grams of calcium and dissolved it in 50 millilitres of water, what would my concentration be? Okay, so I'd use my equation. Okay, so I know my number of moles. I know that 1 mole is equal to the RAM, so the relative atomic mass. So in calcium, 1 mole would be equal to 40 grams, because the atomic mass of calcium is 40. Okay, so I have 20 grams, so that means I must have half a mole. So I can input that. Okay, I know that my volume is normally measured in litres, so I need to convert that figure into litres. Okay, and I do that by dividing it by 1,000, because I know that 1,000 mils is the same as 1 litre. So my concentration is 0.5 divided by 0.05, which is the same as naught, which is the same as, do that in my head, which is the same as 10. Okay, my unit here is moles. My unit here is litres. Okay, so my unit here is moles per litre. Okay, I could also do exactly the same, except instead of using moles, use mass. Okay, so I could also do exactly the same equation, okay, where M is mass and V is volume. Okay, so this time my mass would be 20, my volume would be 0.05, my concentration would be 10,000. This time my units of mass are grams, my units of volume are litres, so it's 10,000 grams per litre. Okay, so we are going to look at some example questions. Okay, what I want you guys to do is make notes on the video and then be able to bring those notes in to look at example calculations. Thank you. Cheers, Jamie.